Welcome back to OneOps User Training Level 1 Beginner. Today we're going to talk about our motivation to use OneOps. Why would we want to do that? To understand that, we have to go back to the basics of how applications are run and what a cloud application is, and then figure out what the advantages are of using a system such as OneOps. Traditional ways of running an application on a server, such as bare metal installations where the operating system is running right on the hardware and your application is running in that operating system, or the usual of normal, more or less static virtual machines, is always sized for the largest loads. It is inefficient in terms of the usage of those resources, of those servers, and it generally not dynamic enough. And that ultimately means it's not competitive and something we don't want to deal with. To avoid these problems and get to a better system, what comes up as a solution is the cloud. The cloud comes to the rescue, but what does that really mean? There's a lot of buzz around this, but you can boil down cloud application and cloud usage to a number of principles. And those would be that, first of all, you want things to be automated. That means that as soon as you are doing something manually, you're probably not doing the right thing. It should be a hands-off approach for all operations. It should be instrumented. So you should understand what is going on with your application, and you should have sufficient monitoring and alerting and so on in place so that you know what is happening with your servers. It should also be resilient. That means that failure is a planned feature, so to speak. You're expecting things to fail, and you should be ready to deal with them. As part of that, to some degree, you also need to have an adaptive system, because change, be that a failure or also a planned change, such as a new release, a special event that will have increased load on your servers and other things, are inevitable, and you need to be ready for them. And last but not least, security is a must in a cloud application, specifically also because it is more complex, there are more moving parts, and therefore also more potential places where things can go wrong. So you need to plan security in from the start. These cloud principles can also be manifested or understood by looking at specific characteristics of a cloud as defined by the NIST Institute. One of them is that it has to or should be a on-demand self-service. So you should be able to get going really fast on your own without having to go through a lot of bureaucracy to get servers purchased or provisioned or put into data centers and so on. You should also have broad network access from anywhere with any sort of devices. In addition, resource pooling should be there so that you can be as efficient as possible. If a server is not utilized to its potential, it should be reduced, and some of its capacity should be made available to other applications in the same network and cloud. In order to adapt to the inevitable change in things like failures, you need to also have rapid elasticity built into your system, which means you can seamlessly scale up or down in terms of the expected load and performance necessary to perform everything as expected so that your users stay happy when using their application. To have all this happening, you also need to measure things. You need to know what is going on, have the usage of various aspects measured, and then only pay for the usage of the resources you are facilitating and not anything that lays around, so that there's no waste for you and no additional cost. Depending on the usage of the cloud, you can characterize them also by different delivery methods. On the one hand, you have what's called software as a service or SaaS, which means that you are consuming an application from the cloud. So you're essentially not in control, you are merely consuming an application that is already there in the cloud, run by yourself or someone else typically, and you're just taking advantage of its features. The next step up in terms of control over what's happening is a platform as a service. So you are leveraging the cloud for your own applications. So you design and develop them, you decide on the features and so on, and then you deploy them in the cloud or in a cloud environment to take advantage of those characteristics for your application. Last but not least, there's infrastructure as a service, where you are actually a cloud. You're providing the features of a cloud, such as compute services, DNS, load balancing, and numerous others. All these clouds can be deployed in different methods and made available to you. On the one hand, they can be public clouds, so they can be owned by a third party and made available to you, and are basically available on the public internet. On the other hand, they can be private, so they are only available to you, which then in turn means that they could be also owned and operated by you, or they could be owned by a third party, but made available to you exclusively as a whole, the whole cloud, not just an application in it, but the whole cloud and all its facility. Or you could have a mixed environment. To stay truly competitive, however, you need to have a mixture of public and private cloud, because you can't run it all on your own. That's too much effort and you need to scale it too much. And you can't just rely on public clouds only either, because you just don't have enough control. Now that we understand a bit about how a cloud is characterized, what the characteristics and how it is delivered to you, what does a cloud application look like? In a nutshell, it could look something like this. You see, this is a simple web application running on a Tomcat server in this example, where those load balancers provide a distribution amongst multiple nodes running multiple web application instances on these separate servers. And the same thing is happening for web services here that these applications use, and then auxiliary services such as caching, messaging, logging, or a NoSQL database. The main takeaway from this picture, however, should be that there is many small nodes, and they are dedicated to different tasks, and each node, because of the load balancers, can potentially break down, and there should be no interruption to the service. So what are some of these characteristics of cloud applications? There's a lot of documentation and ideas around that, for example, at the 12factor.net website. But in general, a cloud application architecture means that there is a loose collection of services that constitute and contribute to some user interface or whatever the purpose of your application is. These small servers have a single purpose each and fulfill a small scope of functionality. Load balancers serves to provide access to the different services, and the data for these different servers is decoupled from the actual servers. Concurrency is used for scale, so you just throw more individual small servers at them, and each one of the individual servers is disposable. So if a failure happens, another one can just pick it up. The load balancer will take it out of the active nodes to receive traffic, and everything will continue to work. So with this usage of a cloud and a cloud application with such an architecture, what advantages do we get? Well, typically you get much higher usage of the underlying hardware at a lower operating cost. Each individual application container is also much less complex and can be easily understood and replaced and managed. And on the other hand, you get really good economies of scale from that usage. Typically, on an average, a move to this more cloud application suitable infrastructure and configuration, typically that means that the utilization of your hardware increases from only about 20% on average to up to 90% and more. And that is a tremendous advantage. So if you have decided to move towards a cloud application, what are you going to do? Well, you can either go to a commercial cloud provider such as Amazon, Microsoft, Google, Rackspace, and others, or you can try to use and be your own provider by using an open source system for a cloud infrastructure such as OpenStack or Apache Cloud Stack. Which one would you want to choose though? Each of these clouds introduces a lock-in in a way. Specific APIs and tools are being used, and migrating from one to another is anything but simple. None of these clouds are available globally either. So if you're a large distributed company that potentially even operates across the globe, you're going to be out of luck and you're going to have to deal with using multiple clouds. That might therefore be necessary, but that is expensive because of those different APIs. You'll also have different advantages for these different clouds over time and location. Some clouds will go offline, others will be online. Some clouds will choose to raise their prices, others will lower their prices. You might want to move. And they will also have varying stability and uptime. So which one should you really choose? Well, essentially, you would want to choose all of them at the same time. So not really choose any. And that can be an expensive proposition. However, OneOps comes to the rescue because OneOps abstracts your application from a specific cloud. So it is, in a sense, the ultimate platform as a service where it doesn't really matter anymore what cloud your application ends up running in. You design your application once and run and manage it in any cloud because OneOps can abstract the notion of the specific APIs and so on of a cloud. And you can just choose all of them at once or switch between them as you like. And you will see this is very beneficial and actually not that hard to do at all. And that's what you're going to learn today. In our next module, we're going to dive into starting that process.